Hello class. Today we're going to continue our discussion with Unit 3, Ratios and Proportions. We're going to talk about some real-life applications as they apply to scale factoring. What's scale factoring? That's when you, for example, take a picture and you want to blow it up into a bigger picture, or you have a big picture and you try to shrink it down into something that you can use on your PowerPoint presentation or Google presentation. Now, a lot of times we just do that with our fingers, grasping and stretching and pulling, but there's some math involved. For example, if you were an architect and you were going to build a new car, you might create a model image of that from your drawing to show the people that you are trying to sell your new car design to before you actually go out and spend the money to build the car at a real life-size drawing. So we see here that the scale factor of this model car is 5 inches wide and 8 inches long. It turns into 5 feet in real life wide and 8 feet long in real life. Here's a scale factor. You see the 5s are the same, but this is stretching from inches into feet. Here we have a drawing of a horse. You may have taken a live horse and redrawn it yourself, but you want to keep it proportional. You know, the eyes are the same distance apart in the drawing as it is in real life. The tail is proportional, just as long compared to the mane in the drawing as in real life. So we see here that the height of the horse may be 5 feet tall in real life, but the drawing might only be 5 inches tall here. It's a lot in images. When we study maps, we're not studying a life-size version of the map. But if it's not scaled right or proportional, it'll look like things are a lot closer or farther than they really are. So, scale factor, again, is a ratio between the corresponding measurements, the sides that line up, of an object and an object that represents that object. With scale factor, we can still solve the missing sides of a triangle, but given only one side. We're still comparing the base here of a triangle to a base here of another triangle, but we know that there's scale involved. It's either getting larger or getting smaller. And we're given, instead of a second side, we're given the ratio. But we're going to use it just like we had 3 given sides and 1x. So the ratio here is 15 to 5. Which one of these triangles do you think is the 15? Well, this one is, because it's the first one, and it's bigger. If one of these had to be 5, you would probably say the smaller one's 5, since this 15 is bigger than 5. So we're going to write our ratio here, 15, just like we would if one of these sides was 15, to 5. In other words, large triangle on top, small triangle on the bottom. Let's keep that consistent. 60 is from the 15 triangle, so we'll put 60 on top. What's from the small triangle? Well, we're only given one thing, we're given x. So then we'll cross multiply. 5 times 60 is 300. And 15 times x is 15x. Now we've been solving these for a long time, so I'm sure you know what to do next. We have to get x alone. So we're going to divide both sides by 15. That cancels the 15 here. We bring the x down. But then what's important to remember is how you type this into your calculator. What's on top goes in first, divided by what's in bottom. Just like 15 comes first and it went on top, 5 came second and it went on the bottom. What is 300 divided by 15? Did you use your calculator? I did too. The answer is 20. Just like if I knew this was 15, and if I knew this side was 5, I was given that ratio. So, in today's lesson, we are going to be solving for x. In the past, we have given you two sides of one triangle and one side of the other with an x. And we've set up our ratios. Big triangle, or first triangle to second triangle. First triangle to second, first to second. This time, instead, we are going to use a ratio. So in this first set of fractions, we are going to use 4 to 3. 4 is the first number, goes on top. 3 is the second number, it goes on the bottom. We also need to notice this. This is A to B. So on this side, we are going to line up the A triangle side. A triangle is 164. B is x. Sometimes you will see that x will appear on the A triangle. So sometimes if it says A to B, x will be on top if x is over here and the number is over there. We're still going to cross multiply and divide. We're just given a ratio this time instead of the sides of a shape. Any questions? Sometimes we're given the information in a story problem. In this story problem, we see there's a tree and it says it's 75 feet tall. Miss Amy needs to draw a tree for our class. If her scale factor is 24 feet to 5 inches, how tall will the tree be? Well, 24 feet to 5 inches. Is her drawing going to be in inches or feet? If we go 24 feet to 5 inches, feet over inches, over here we need to have feet on top, inches on the bottom. How many feet is the original tree? 75. So where does that go? 24 feet to 5 inches, feet over inches. Yes, 75 goes up there. Have a good day.